and strength. The batsuit. The batsuit has been a key part of its owner's mystique from the very beginning, but it wasn't always a source of protection.
It starts as a symbol, a creature of the night, something to terrify. It's designed to make you A, anonymous, B, more than human, all at the same time.
Originally, Batman's suit was made of cloth. It could be easily torn and didn't include any special technology.
The first evolution of the Batman suit takes place in the late 1950s. The editors felt that strange, weird new looks were part of how to sell the story. You would do stories like Undersea Batman, where there would be a special Batman costume just for going underwater. And that began the introduction of the suit as technology.
Given the weaponry that he's facing and the situations he's created, you have to believe he needs more in his arsenal in order to combat the greater threat that he keeps on facing.
The whole idea of it becoming essentially a suit of armor evolved over the years.
The inspiration for some of the technology of the batsuit was almost accidental. When DC artists added a yellow circle to the suit, one that looked like a bullseye, writers were inspired to add a new aspect to the outfit.
When they started addressing the question of it being a bullseye, they took that opportunity to go, well, yeah, okay, then it is a bullseye. He wears Kevlar behind that section of the costume, hoping that criminals will actually fire at that, and it's bulletproof. Well, once you start doing that, the next logical question is, well, if you're going to wear Kevlar there, why aren't you wearing Kevlar under the entire costume?
Kevlar bi-weave, reinforced joints.
Tear-resistant.
This sucker will stop a knife.
Bulletproof.
Anything but a straight shot.
Kevlar's cool. It's 5 times stronger than steel, and when woven in layers, like 3 to 7 layers, it will protect the body.
Developed by DuPont in 1965, Kevlar material gets its life-saving properties from the unique way its synthetic fibers are woven.
In Kevlar, you have a bunch of fibers that are interweaved with each other, and so as they get hit, they actually stretch. The individual threads are fighting against each other, and it can resist very large impacts and high-speed bullets without actually breaking. So if you have a suit made of Kevlar and you want to know how close you can be to someone who's shooting at you, interesting question is less the range than the actual size of the bullet and the speed. And Kevlar vests can cover a wide range, and most, hand pistols and even some shotguns, Batman would be very safe against, even up at close range.
In The Dark Knight, Batman's Kevlar suit gets an upgrade to the next level in defensive gear.
I'd been looking for the story reasons for redesigning the suit, and then it occurred to me it's actually very simple. We just would have it be the real reason we did redesign it, which is he wants to be able to move faster and more flexibly. That's what we put into the story.
Hardened Kevlar plates over titanium-dipped tri-weave fibers for flexibility. It'll be lighter, faster, more agile. Perhaps you should read the instructions first.
We collected together, read about and looked at all these sort of Under Armour suits, what the Army use. So we just set about redesigning the suit. We see that it's made up of much more facets, like a suit of armor.
The separate plates of armor of the new Batsuit are anchored on an elastic mesh.
It's 110 components to this suit. We decided that smaller armored plates would allow a crumple zone between those armored plates and allow him more movement.
The Batsuit's flexible, armor-plated design parallels an actual technology called ceramic armor, made by companies like Ceradyne Incorporated in Costa Mesa, California. Their ceramic plating has the resistance of steel, the material that's long been used to stop bullets. But ceramic plating is 70% lighter.
To stop the bullet, you have to break the bullet. Therefore, you need something that is harder than the bullet. The lightest weight, hardest material known to man for these types of applications is known as boron carbide.
Boron carbide is a black crystalline powder. When heated to extreme temperatures and formed into ceramic plating, it becomes nearly as hard as diamonds.
So where you are right now are in the hot pressing area. This is where we take a powder and we make it into the lightest, hardest material known to man.
Transforming the particles into armor begins by pouring the powder into forms. and then compressing the material. The armor molds are then put into a hot press.
And behind me, you can see the hot presses. These are induction heated, and they operate at temperatures close to 4,000 degrees Fahrenheit.
The plates are then cooled, but they're not safe to be used as armor yet.
In certain high impacts, ceramic armor plating still will shatter. But that's actually a benefit because it really dissipates the energy into the shattering of the material instead of your body.
But shards of shattered ceramic plating can still be deadly if they enter the body. To prevent this lethal possibility, a special resin is fused to the back of each piece of